Hi, this is John Isles and welcome to Geometer's Paradise. Today we are going to learn how to bisect an angle by drawing an angle bisector. Bisector, remember, is a line or part of a line that divides an angle into two smaller angles with equal measures. So, like the segment bisector, the angle bisector has a lot going on under the hood, which depends on knowing something about triangle congruence, which we don't yet. Fortunately, like the segment bisector, GeoGebra provides us a tool to make life simple for a while. Let's start by drawing angle BAC, and we're going to do that by putting a ray down. So there's ray AB, and then here's ray AC. And then place the angle bisector by selecting the angle bisector tool and then making 3 clicks. So click on B and then A and then C to place the angle bisector of BAC. Now let's place point D on the angle bisector, and then angles BAD and DAC have equal measures and so are congruent angles. As with segment bisectors, angle bisectors have 2 primary calculations. You're either going to start with one of these smaller angles and then double it to get the larger one, or you're going to start with the larger one and then halve the value to get the smaller one. For example, AD is a bisector of angle BAC. If the measure of angle BAC, the larger angle, is 60, then the measures of angles BAD and DAC are both 60 divided by 2, which is 30 degrees. Now let's suppose that we start with the measure of angle BAD, which is 45. Since AD is a bisector of BAC, that means DAC is also 45, and if I want the measure of BAC, 45 times 2 is 90 degrees. These calculations hold even if algebraic expressions are given for any of the angles. Let's suppose that BAD is 10x and BAC is 80. Again, remember that 2 times BAD is equal to BAC, so 2 times 10x is equal to 80. Verifying that the bisector actually makes congruent angles is a bit involved, so I chose to leave it to the end of the video. Start by dragging D closer to the vertex of the angle, and then draw a circle with radius AD passing through A. We want to intersect the circle with the top ray of the angle and the bottom ray of the angle, and then draw a circle with radius DE and center D. Notice that if I drag this out, that the circle stays linked to those 2 points E and F, the intersections of this larger circle and the 2 rays. And that tells us that this distance, ED, this arc, is the same length as this arc, which in turn tells us that angle BAD has the same measure as DAC. So angle BAD and angle DAC are congruent angles. Now, the angle bisector tool will accept just 2 arguments instead of 3. We said that when you click the angle bisector tool, you want to click on the 3 points in order, B and then the vertex and then C. Okay? Well, you can just click on the lines, but when you do that, what happens is that you actually generate bisectors for 4 different angles. The angle we're looking at, the angle vertical to that angle, which you can't see, and the angles supplementary to this angle, which you can't see. And a lot of those are topics that we'll talk about later. But just so maybe we can clarify a little bit here. Oop, no, we want those to stay red. All right, let's get a line tool out here and black lines. So they're all right. I'm going to click on BA to draw a line, and I'm going to click on CA to draw a line. And now you can see a little better that these 3 angles over here are being bisected by the red lines in addition to this one. So if you just click on the sides, you're going to get a little more than you bargained for, which is why we say click on the points to set the bisector of an angle.